Hello everyone, in this video we're going to look at the homework and the first problem. A marketing expert for pasta making company believe that proportion is 30% P equal 0.3, non-hypothesis. Loves prefer lasagna. If 10 out of 20 pasta lovers choose lasagna over the other pastas. Okay, what can be concluded about the expert claim? So what do we have? The alternative hypothesis is P not equal. We don't have less than, bigger than, so it's not equal. And they test a binomial variable. This is a small sample. X equals 10, N equals 20, and P equals 0.3. It's a small sample, so we use binomial distribution. So you just type in this, and we'll find a p-value. P is a probability. P-value is probability. So it's P x bigger than 10. Okay, and not equal 0.3, right? Not equal 0.3. So it's 2 tests. Okay, so you do that. It's going to be double, not equal, double. Both tails is 2 times probability of that, so it is 2 times probability of 1 minus the probability x less than equal to 9. 2 times that, so it's 2 times 1 minus n equals 20, n equals 20, 29, so yes, 1 minus 0.9520, which is it's going to be calculator. Let me see. So we got is 1 minus 0.9520 equal times 2 equals, let's say it's 0.9096 and 0.9096, and then we compare this one with 0.01. Right, 0.01, this is, so this is bigger than the significance level. P is high. P is higher than that. P is no, which non-hypothesis go. P is high, non-hypothesis fly. So we don't reject the non-hypothesis. There's not sufficient evidence that the percentage of pasta lovers prefer that is not 30%. Okay, so this is the first problem. That's the second problem. A certain college is estimated that at most 24. So at the most 24%. When you say at most, it means the non-hypothesis is our native non-hypothesis is always 0.24. So our native hypothesis is going to be at most, which is this side, right? At most is this side. So our native hypothesis is this side. So the P is bigger than 0.24. If I find something in this side, so I reject this, then I reject the non-hypothesis. Okay, so the alternative hypothesis is P is bigger than 0.24. So the same to be valid estimate if the random. So now I have a sample, give me 27 out of 96. Okay, so what do we do? This is a large sample. Large sample is what? Large sample is going to be a normal distribution. So what do? I use z equals p minus p0 over p0 over q0 over n. Basically, you can do z equals p is 27 over 96 minus 0.24 square root of 0.24 times 0.76 over 96, and find z score, which is 0.95. Okay, or you can use the StatCrunch to do that problem. Let me see the StatCrunch. Where is the StatCrunch? Let me have the StatCrunch do that problem. Okay, you can open the StatCrunch, and do I have it on the square StatCrunch? If not, I just take it out. So now let's see if you use StatCrunch to do this problem. You can just type in Okay, just type in this problem, and we got stat and P equals proportion stats, one sample with the summary, proportion test summary. Okay, over success is, you got success is 27. So you just type in 27. Observation is 96, and hypothesis test is 0.24. Wait, 24, and which is bigger than. Okay, so compute. Got z-score is 0.94, and the p-value is 0.172. P, compare the p with what value? With the 0.05. P is bigger than 0.05. Do not reject a null hypothesis. P is high, so not reject. P is high, null hypothesis fly. So we do not reject it because P is 0.172, which is bigger than okay, how you got it the 1.65? I didn't introduce that. How you got 1.65? Because it says 0.005 level, 0.00 level. So you get is one tail test. So which means this is 0.005, and the left side here is 0.95. According to the table, let's find out the table 0.95. 0.95, which is 9505. 9495 is here. 1.601234. So it's 1.645 between these two. Just between these two numbers. So it's 1.645. You can do 1.64 or 1.65. Either one should be 5. So you do 1.65. So that's how you got the z-score equals 1.65. Give you the value 0.95 according to the table. Okay, 0.95 is right here. So it's z-score is 1.645 or 1.65. So you got z is that is a lot bigger than that. So we do not reject it. Okay, it's number 2. Number 3, you got a study that estimate is the same. You got P1 equal P2. You find the test the statistics, find p-value. The same. You can use that. You can use the StatCrunch to do that. Proportion test, 2 sample summary. What you can do, you can type in all the numbers. First one is what? 75, 125. So 75, 125, 38 out of 20, 38 out of 80, and P1 not equal P2 significance level. Okay, so it says if there's a difference means not equal, right? So P1 plus minus P2 equals 0. P1 not equal P2 is the same. So compute. You got a z-score. Wait, let me check it again. So proportion 7, proportion test 7 out of 125 in that P1 P2. $75, 125, 38, 32. That's why. So 32. Compute. You got the z-score is 2.79 is 2.8. P-value is 0.005, which is very small compared with the value significance level. Whatever significance level you give is really small. It's 0.0005. 0.005 is very small, so P is small, P is low, null hypothesis must go. So reject the null hypothesis because there is significance, they are different, and the null hypothesis must be rejected because significance level is bigger than the p-value. P is small. Okay, P is the probability. All right. So next one is chi-square distribution. Okay, so the first one is pretty simple, and chi-square equals 49. The other chi-square is less than, it says. sigma, my bad. Sigma squared equals 49. Sigma is less than 7, so sigma squared is less than 49. That's alternative hypothesis. This is pretty simple. Sigma less than square less than sigma equals sigma square equals. So now we need to find the chi-square distribution. What you can do, you can use variance test. Variance test, one sample with summary. Sample variance, you can do sample variance. Well, even you don't use this StatCrunch, you can use a -1 square over s square over sigma square, which is the same. Okay, so sample variance is 49. And sample size is 25. And this is sigma square equals 49. And sigma is bigger than, less than 49. Compute. You got the chi-square. P-value is point. Chi-square is less than, okay, so it's less than 14. Variance, one sample variance. Yes, one sample variance. Oh, my bad. I think I made a mistake. So added it. Okay, what do I do? Stat variance proportion, variance stats, 2 sample actually. Because this sample, the sample size first one is 47, is 49. So 49 plus 1 is 49. Sample sigma square, the other sigma is sample size is 25. Variance is s square. 25. S is 5.37. 5.37 multiplied by 5.37 square. 28.8369. Okay, 28.8369. Okay, less than 1. Wait, t-test the chi-square distribution. I think it should be. Wait, how did I do this one? Chi sigma equals. So if I use the formula is chi-square equals m-1 s square over sigma square. So it's is 25 minus 1 times 5.73 square over sigma square, which is 49. Let me see. I think this is how you use the formula to do that. But I should be able to use that too as well. Let me see. Just first I use the formula to do it first. So 24 times 25 minus 1 equal 24 times 5.37 square equals divided by 49 equals, okay, you got this formula, you got 14.12. Okay, that's how you do that chi-square. But if I use the, let me see if I can use a StatCrunch to do it. StatCrunch proportion variance, not is variance test. One sample with the data with the summary. I think it's with power with the summary, right? Sample variance. Oh, I think I got it wrong. I know how to do it now. So what I need to do, I need to type in sample size is still 25, but the sample variance I type in here should be what's that, 38. Where's my calculator? Okay, calculator. So F is 5.37 square, 28.8369. Okay, 28.8369, and the variance is 49. The other one is less than. Compute. So now you get the same chi-square value as the formula. If you use the formula, you should get the same chi-square value. So now you compare this one with the critical value. If it's less than, you can look at the chi-square. This one give you the p-value is 0.05. P is 0.0562. Well, compare with the 0.1 is less than, p is small, rejected. So you know it's reject null hypothesis, okay? And the critical value is p, sigma chi-square is less than this. How do I find a chi? How do I do this chi-square less than 15.66? What do you need to do? You have to use a table, okay? And now the level is 0.1. And you can tell that it's less than, so you've used the table. And freedom is 24, v equals 24, but do I have 24 here? Oh, we do have 24 here. So for 24, if this is less than, so this is 0.1, you can use, let me see. Okay, so it's 0.1, so left side, if it's less than that, you got less than that, then you got this is 0.1 and this is 0.9. Because it's left tail test. This is left tail. It's less than, so it's left tail. Left tail give you 0.1. So you got right tail here. Because this give you, this alpha, this chi-square distribution give you 0.9. So let's do 0.9, go to 24. 24.9 is this one here. 15.65. 15.66. Okay, so it's 659. So it's rounded up from 15.66. Okay, so now I find that's how you do this. Go to 0.9 because the left tail is 0.1, right tail is, this area is 0.9. Go to 0.9, go down to 24 is 15.69. And now you get the test statistics is 14.12. Number 5, this one you can use that copy it and Control C. Copy that into the statistics and copy it. Control V. Okay. So what we need to do, we can use the stat proportion variance stat to sample data, and we choose the first one, choose the second one, equals 1. Okay, not equal 1 to compute. You get F equals, P is 0.004, F the freedom is 24, and this is 0.000, so it's very small. You put in 24 here, degree of freedom. P value is 0.000, is this one. Reject null hypothesis because this is really small. We have sufficient evidence that they are not equal. Okay. Or what you can do next? What you can do? You can use f equals s1 square over s2 square and find the f value. Use the f distribution. You should be able to do it as well. Number 6. Okay, number 6. You can do the same thing. You can do Control C, copy that, and put in the. Okay, so stats. I need to use another one. So copy, Control C, Control V, Control V, paste it. Okay, so what do you have here? You got that, and this is what goodness feet. Okay, chi-square. And the first one is, wait, all of them, right? So observed. Okay, expected. This is observed is V2 because x1, 2, 3, 4, 5, 6 is not observed value, it's just variable. The frequency variable 2 is the observed value. So variable 2 is the frequency, is observed value. X is just a variable, it's not observed. So variable 2 is observed. But all cells have equal proportion. So all cells equal proportion because it's die is 1 out of 6, equal proportion. compute. And you have the chi-square is 12.31 here. And the critical region, how do you find a critical region? Critical region, you have 312, right? 312 times. So you got your freedom, degree of freedom is 5, okay? So let's look at the degree of freedom. It's 5, and it says degree of freedom is 5 and 0.01 significance level. 0.01 significance level and 0.01 at 15.086, 15.09. So you got the significance level is 0.01. Go to here, degree of freedom is 5, and go to here is 15.086. Okay, and chi-square equals 12.31 is a lot less than. So it's not bigger than this one, so we do not reject it. Do not reject it. And p-value is bigger than. You can look at p-value as well. P-value is 0.03, and which is bigger than 0.01. So p is bigger. P is high. Null hypothesis fly. So we do not reject null hypothesis. Okay, problem 7 is a little bit. We cannot. I have not find a way to use the StatCrunch to do it. So we have to use the formula of chi-square equals OI square OI minus EI. So observed minus EI square over EI, and EI equals row total times column total divided by grand total, and then plug it into this formula. That's what you need to find a chi-square. Okay, so the critical value, the degree of freedom is m minus 1. Sorry, is r minus 1 times c minus 1. So now we have two rows. So I have 2 minus 1 times 3 columns. So 3 minus 1, which is 2. Degree of freedom is 2, and degree of freedom is 2, and we find out degree of freedom is 1, is 2, and the value is 0.1. So if it's 0.1 habit, so it's 0.1. The critical value is 0.1 here. Right. So now we look at a 0.1. Let's see. It's okay. So is 2 is right here. 0.1 degree of freedom is 2, so go to 0.01, so it's 4.6, and it's still 4.6 here. So just type in 4.61 here. So how do I find a chi-square distribution? That's the problem. How do I find a chi-square distribution here? How do I do the chi-square distribution? I did find a way to do that. Use the I used the Excel to do all of the work. Okay, so I'm going to show you all of them again, how I did it. Okay, so it's a little bit, if you use your computer, it's much quicker, because I'm using my the tablet. It's not that quick, especially when I use that to do that. So basically this one, I type in the sum of these 3. Let me say the sum of these 3 is 77, so I type in 77 here. So I type in 77. This one 53 plus 50, I need to add it. 53 add 28. Well, I don't have to do that, just choose the 3. Is 102. So you type in 102. You can type in this one, add the column is 74. Add this to column is 59. Add this to column is 46. Okay, so the grand total is add this together. 77 plus 102 is 180. 179, right? 179. So basically, let me see. 74 plus, 74 plus, why do I do that? 74 plus 59 is 14. Wait, why do I have 180? 179 for that one. And is it 103? Oh, it's 103 for this 103. So together is 180. It should be the same sum because you add the column and if you add the column and the row should be the same. 102. Okay, so let me check. 179. Okay, this is still 179. Okay, so this is 179. So I need to do next. I need to do that. Find out the expected value. Find the EI. This is the total. So the EI equals. If you know that EI is row total times column total divided by grand total. So right here I can use equals column total multiplied by row total divided by grand total equals. I can do the same thing on this one. Equals column total multiplied by this one divided by the grand total equals, and this equals. If you do if you use a computer to do that, you can just drag it and give you that. It's much quicker. Let me see if I can drag it. No, I cannot. So if you use that, you can drag it. Okay, so multiply by say 10 more. Wait, I do that wrong. Equals this one times this one divided by the grand total equals. So this one equals 74 times column total divided by 179 equals 59 multiplied by row total divided by column total divided grand total equals 46 times this total divided by this total equals. Okay, so now what I need to do, I need to subtract it. I need to find out this one. Okay, so what I do use equals parenthesis OI minus EI. So it's OI minus EI parenthesis back square divided by EI. Okay, so this one is the same thing. If you use your computer, you will have a very easy way to do it. You can just drag it. Okay, so 31 subtract this one, this back square divided by the E1 E2 equals parenthesis 25 subtract the EI parenthesis back square divided by EI equals this one equals parenthesis 33 minus 2 next one parenthesis back square divided by EI equals parenthesis 28 minus this one parenthesis back square divided by E expected value equals parenthesis 21 minus this one parenthesis back square divided by this one divided by this one. Oh, I forgot a square divided by this one equals. So now, and this is a summation, right? Sum of that. So what you need to do is just choose this 6. What's the sum? 11, the sum here, sum is right here, sum in the corner here. Sum is 11. You know the sum here, if you choose the 6 here, it gives you sum is chi-square equals the sum equals 11.02. 5. So it's 11.03. Let me see. Wait, 11.06. Something. This one E4. This one E4. D3 minus D8 over square D4. Okay, so somewhere E4 holding or E4. Okay, so it should be right. Let me see. 11.03, 11.03, 11.06. It should be something. Maybe I do something wrong. 25 minus that over D25. D2 minus D7 square over D7. D3 minus D8 square over D8. C3 over C3 over C8. C2 minus 7. B2 minus L V square B7. B3 over B8 over square B7. Okay, it should be this way to do it. Okay, I think I did it right, but if you don't, this is how you do it. You can use handwriting calculator to do that work, to do this job. And I just did it previously. It gave me that. I don't know why. This time it gave me 11.025. It's 11.06. That's how you do it anyway. Okay. The next problem is the same way to do it. It's exactly the same way. You have the table. So you can do exactly the same way I did all of this in the same way in the Excel or in the computer, but it's much faster because I can drag it instead of click. But that's the way you do it. Use this formula find the E. Okay, so number 9, you can repeat. It's exactly the same formula. Okay, number 9. It's not really hard. You just choose that. I did this. It's not really special way. Number 10. Okay, number 10 is you can use the oh, I don't even use that. StatCrunch proportion test. I think it's proportion 2 sample. Proportion 2 sample with summary. Number of success. So what do is you just type in 58. Type in this one 58 over 250. No, 250. The second one you do 68. You do 500, and then it says one of them is bigger than the other, right? So this is bigger than on the computer. You got the Z is 3.31 and Z is bigger than that. Z is bigger than it, so you reject it. You have the p-value is 0.0005. It's very small compared with the 0.1. P is compared with the 0.1 is small, so P is low. Null hypothesis must go. And then how do you find 1.28? Because it's right tail test. Because this is right tail test. Right tail test give you this is 0.01. Right tail test, and this area is 0.9. So you find 0.9 from the distribution. 0.9. 0.9 is right here. 0.9, right? 0.9 here, some. Okay, right here. So it's 1.2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1.28 or 1.29, either one is okay. So you just put 1.28, it's right here, give you 0.9 area, give you 90% probability. Okay, so you can type into 1.8, Z is bigger than that. If Z is bigger than that, you have to reject it. Z is 3.31, is in this area now. Z is right here, so it rejects the null hypothesis. Okay, that's the whole homework.